My dear friends. So in this short module, we will look at the systematic procedure for analysis of organic compounds. So we can divide this into three main parts, which is preliminary test, where we look at the order, color, whether it's the compound is organic compound is saturated, unsaturated, whether it is aromatic or not, and then we'll do test for nitrogen to see whether the given compound contains any functional group containing the nitrogen atom, and then we'll do about 8 to 9 tests to decide on the preliminary functional group of these organic compounds. And finally, once we have an idea of the functional group, we will look at the confirmatory test and confirm the functional groups that we have in our compound. So now we will begin with the first test, which is observing the color of the given compound. So most of the organic compounds, solid organic compounds, are white in color, and some of the organic compound which is in liquid might have like yellowish tinge, which indicates that those may belong to aromatic amine. So based on the color, we can actually come to some sort of conclusion about the functional group. Next is the odor of the substance. So what you do is, usually aromatic amines have a very characteristic fishy odor. Just observe the smell and you will see that if it is like very fishy odor, then it indicates that it's aromatic amine, and if it's like carbolic odor, it indicates that you have a phenol compound. So these are all very indicative tests. The next test is the litmus test, where you take your compound, dissolve it in water, and then use the litmus paper to see whether it is an acid or a base. So the organic compound that I have taken here does not dissolve in water. So what I do, I just warm it slightly. So that to an extent it dissolves the organic compound. Then you take the blue litmus paper and check whether it's an acid or a base. So I'll see that the blue litmus paper has turned red, which tells you that it's an acid. So the next one is whether to check whether the given compound is soluble in water or not, and so this tells you if the compound is soluble in water, it tells you that it's a diamide or a carbohydrate. If it's soluble in water upon heating, then it tells you that it's an acid, which can be a dicarboxylic acid or a monocarboxylic acid. I just demonstrated to you during our litmus test that the organic compound which did not dissolve in cold water dissolved upon heating. So the next test is for the fifth test is for testing whether your given organic compound is a saturated or an unsaturated compound. So for that, you just take your compound in a little bit of the compound in the test tube, and to this you add bromine water. If the bromine water, which is, as you can see, it's pale yellow color, if it is decolorized, it tells you that the given compound is an unsaturated compound. That means there is a double bond in the given compound. Similarly, you can also test for unsaturation by taking some amount of the substance and pouring a very dilute solution of KMnO4. So what I do, I just take 2-3 drops of KMnO4, I dilute it, and then I add this diluted KMnO4 to the compound, and if it decolorizes, it tells you that it's an unsaturated compound. You can see that the pinkish color has turned to brownish, which means that it decolorizes and your given compound is an unsaturated compound. So the next test that we are going to perform is called as the ignition test, where you take the compound in the spatula and you just heat the compound vigorously. So if it ignites with the black fumes, as you observe, it tells you that it's an aromatic compound. If it doesn't ignite, so if it is an aliphatic compound, it will not give that black smoke. So you can see that it's not an aromatic compound. So you can see the difference between an aromatic compound and a aliphatic compound. I will demonstrate to you how do you test for the elements present in your organic compound. We will look for the nitrogen. How do you do the test for or how do you collect the sodium fusion extract using the sodium metal. So this test is a little bit on the riskier side because it involves sodium, and sodium is highly reactive with water, and so while you are handling sodium which is kept in kerosene, you should be very careful that you don't disperse it in water, otherwise it will explode. So uttermost care is required while doing this experiment. So sodium is usually kept in kerosene. You take a very small piece of sodium, you take the filter paper and put that small piece of sodium in this tissue paper, and you wipe off all the kerosene that is over the surface, and then you take this dried sodium into the sodium fusion tube. So you can see that the sodium fusion for this sodium fusion extract preparation, you need sodium metal. So you will see that this is the sodium which is at the bottom, and so the test has to be conducted in this manner. You will heat this sodium until it's until it's melts, and when it melts it becomes a little shiny, and that's an indication of when you have to drop your substance that you have taken in the spatula. So this is like a very dull grayish color of sodium, but upon heating this turns into a slight silverish, and at that moment you have to add the your substance. So I'm going to heat this, and at the same moment I'm going to observe it, and I'm going to add the substance that I have in my hand. So it has turned. So I'm now I have to heat it really very strongly. You will observe that the bottom of the test tube turns red. So I have to heat really so long, for such a long time, that it really turns red. Yeah, so now you see that it has turned red, and at this moment you have to plunge this hot test tube into a beaker which contains about 15 to 10 ml of water, and you have to break this test tube, and you take glass rod and you break this fusion tube, mix it well, and then heat this mixture for about say 30 seconds or so. And this filter and this extract, so this filtrate is now collected. So use a filter paper to collect this extract, and the rest of the text you will do with this extract. Okay. So the way you add this filter paper on top of the test tube is, you just take your filter paper, fold it into two half, then again into another fold, and what you do is that when you divide this in this manner, make sure that on one side there are three three folds, and on another side there is a single fold, and then you just keep it on top of the funnel, and this is how you prepare your funnel for filtering the extract. So now we will do the test for sodium presence of nitrogen. So from this extract you take some amount of this extract, and then you have to add ferrous sulfate, like 1 spatula of ferrous sulfate. So I'll add 1 spatula of ferrous sulfate. Shake well so that it's completely dissolved, and then you heat this for a while, so till it boils, till you observe that it's boiling. So whenever you heat it, make sure that you don't hold the test tube constantly, but no, you just shake off so that it doesn't, the liquid doesn't pop out. So always move the test tube. Yeah. So now it has heated well. Now you allow it to cool down for some time. Don't immediately keep it under a tap water. What will happen is that if it's this hot test tube is kept under the tap water, a crack can develop and it can also explode and spill on you. So what you do is just wait for some time, and then you can just run cold water on top. So once this is done, you then add few drops of concentrated HCl. So I'm just going to add few drops of concentrated HCl. Okay. So now you would have observed that the solution, which was brownish, has now turned to blue green, which indicates the presence of nitrogen. If it doesn't turn to either green or blue green, it tells you that your compound doesn't have nitrogen. So this is a very important test to decide whether the functional group that you would estimate contains nitrogen or not. So if this test is answered, that is if your solution turns bluish green, it means that it can be an amide, it can be aniline, it can be say a nitro compound, and so on.
Now we shall see how we test the presence of acid as a preliminary test. The first test we are going to perform is action of sodium bicarbonate. The sodium bicarbonate test is one of the tests to confirm the presence of acid. Take the sodium bicarbonate in a test tube and dissolve it in water. Dissolve it in water. And dissolve it in water, and then take your substance, and pour it. Take the substance, little bit of the substance, and add it, and you will see the brisk effervescence. Okay, you can see the brisk effervescence, or you can also hear the brisk effervescence. Okay, this is how. This is the way. If your substance get brisk effervescence, then it shows the presence of carboxylic acid. If the substance doesn't, if you don't observe any brisk effervescence, then the compound is not acid. Okay. Next, the presence of acid can also be tested using sodium hydroxide. The acid will be dissolved in sodium hydroxide, and when you add HCl, the dissolved acid will get regenerated. We can test that also. Take the little amount of your substance. Take little amount of your substance. You can add sodium hydroxide. You can add sodium hydroxide. You can see there is, I have taken the acid, and if you add sodium hydroxide, it will get dissolved. You can see the completely it is dissolved. Completely dissolved. Okay. When you add HCl to this, the dissolved acid will get regenerated. The dissolved acid is regenerated. You can see the formation of a white color precipitate. That means the dissolved acid regenerated. Okay. And this is how by the test acid and phenol will respond to this test positively, but the sodium bicarbonate test will distinguish between phenol and acid. Phenol will also be dissolved in NaOH and will be regenerated using HCl, but the brisk effervescence, only acids will give positive result. Okay. The next we shall see the action of concentrated HCl test, and this test is for to detect the presence of amine or bases, organic bases. In the same way, if you take the substance, we have here. The same way, you can take your substance. If your compound is amine, it will be dissolved in HCl. If you add HCl, it will get dissolved, and if you add NaOH, it will get reprecipitated. Okay. But the dissolution of amine can be seen when you add water, and there won't be any two layers. That means it is dissolved. Okay, it is dissolved. When you add NaOH, you can see there is a two layers developed. That is how you can find. Okay, now it is regenerated. Now it is regenerated. The water and amine is separated. Okay, and this shows the presence of amine or base, organic base in your compound. These are all the preliminary tests to detect the presence of carboxylic acid and the presence of amine. And then next we shall see the test for carbohydrate. Carbohydrate can be tested using sulfuric acid. The preliminary test for carbohydrate is now we shall see the test for carbohydrate. Carbohydrate can be tested by taking the little amount of substance and taking few drops of concentrated sulfuric acid and heat it in the burner, and you will get the blackening of the substance. Okay, this is called as charring, and this charring shows the presence of a carbohydrate in your substance. Next we shall see the presence of aldehyde. For this we need to perform Borch's test. We take little amount of the substance and then just add Wait பண்ணுங்க, procedure பார்த்துக்கிறேன். Now we shall see the test for aldehyde and ketone. Both aldehyde and ketone give a positive test for Borch's test. Okay, in order to do the test, you take a little amount of the substance and add little amount of alcohol. Actually, that is rectified spirit. And you have to add that and dissolve the substance in rectified spirit. And then add Borch's reagent. Add Borch's reagent. The formation of yellow color shows the presence of aldehyde or ketone. Both aldehyde and ketone will give a positive test for the formation of yellow color. This yellow color precipitate, actually the formation of yellow color precipitate shows the presence of aldehyde or ketone. Okay, we will distinguish whether the compound is aldehyde or ketone using legal test that we will see later. Now we shall see the test for phenol. In order to test phenol, we have to take a little amount of the substance and then dissolve it in alcohol. Dissolve it in alcohol and add freshly prepared neutral ferric chloride into this. Formation of this violet color indicates the presence of phenol. Now we shall see the test to detect amides. In order to do that, take your substance, add a little bit of sodium soda lime. Take little bit of soda lime and then heat. When you heat, you will get the smell of ammonia. The smell of ammonia can be detected using a glass rod dipped in concentrated hydrochloric acid. A glass rod dipped in concentrated hydrochloric acid. Okay. Now, while heating, place the glass rod dipped in concentrated hydrochloric acid. You will get a dense flame. You will get dense fumes. The formation of this dense fumes, dense white color fumes, indicate the presence of amide. The ammonia gas reacts with ammonium chloride, ammonia to form ammonium chloride. The ammonium chloride actually visible as a dense fume. Okay, this is all the preliminary test for all the functional group. After this, we will come to know what type of functional group we get in our compound. Then we will confirm whether the functional group we detected is correct or not by repeatedly doing 2 or 3 experiments. Okay, now we shall see the confirmative test. Once you detect the presence of some functional groups, you have to confirm it and confirm it by doing some more experiments. Okay, in that now we are going to see the confirmative test for dicarboxylic acid. Okay, when you get a positive result in a preliminary test for acid, whether you have to confirm whether the functional group is monocarboxylic acid or dicarboxylic acid. I am going to perform a test called fluorescence test. From that we shall confirm whether the compound is monocarboxylic acid or dicarboxylic acid. In order to do this, before going into the experiment, I have to prepare sodium hydroxide solution. Take a beaker and add water, full of water. Okay, and then add a little amount of sodium hydroxide in it and keep this solution ready before you doing the experiment. Okay, I kept the water ready. Now you take the substance, take the given substance, add resorcinol to this, and few drops of concentrated sulfuric acid. Then heat the contents. The content will turn brownish or dark color. Once it turned into dark color, add 1 drop of this to the already prepared sodium hydroxide solution in the beaker. Just 1 drop is enough, and you will get a beautiful fluorescent green color. This fluorescent green color shows the presence of dicarboxylic acid, and the beauty of this experiment is if you dilute the solution more and more, you will get the color, more beautiful color. Okay, if you dilute more and more, and the color will not fade away. Okay, you will get beautiful greenish yellow color. Okay, this shows the presence of dicarboxylic acid. If you don't get this fluorescent yellow color, that means your compound may be monocarboxylic acid. Now we shall see the confirmatory test for aldehyde and ketone. In the preliminary test, if you get a positive result for Borch's reagent, it shows the presence of aldehyde or ketone. You have to confirm whether the compound is aldehyde or ketone. For that, you need to do Schiff test. Okay, take a little amount of the substance and add a Schiff reagent. Add a Schiff reagent, and you will get the formation of pink color. Okay, this color, formation of this color shows the presence of aldehyde. If the compound is ketone, you have to do a test called legal test. If you do the legal test, and you will get a positive result for ketone, aldehyde will not show positive result for this test. You take a little amount of the given substance. Take little amount of the given substance, and to this add sodium nitroprusside. And then add 1 ml of sodium hydroxide, and then add few drops of glacial acetic acid. Formation of this dark color, this dark brown color shows the presence of ketone. Either this dark brown color or dark violet color, this shows the presence of ketone. Now we shall see the confirmatory test for carbohydrate. To confirm the carbohydrate, we are doing a test called Mollis test. Before you do this experiment, we need alcoholic alpha naphthol. Before we start the experiment, let us prepare. You take alpha naphthol and dissolve it in alcohol. That is alcoholic alpha naphthol. Dissolve. You have to I am taking alpha naphthol and dissolving it in alcohol. Okay, this solution is alcoholic alpha naphthol. Okay, now we shall continue the experiment. For this experiment, you have to take the given substance. The given substance, add little amount of water and dissolve it in water and add a little amount of alcoholic alpha naphthol. Okay, after adding alcoholic alpha naphthol, you have to add the sulfuric acid. Add the sulfuric acid along the sides of the tube slowly without shaking. There will be formation of violet color ring. You can see the ring. You can see the ring formed. Okay, this formation of violet ring shows the presence of a carbohydrate. This is the Mollis test. Okay, violet ring. If you add concentrated sulfuric acid slowly, then without shaking, you will get a violet ring. If you shake, the violet color spread over. Another test to confirm the presence of carbohydrate is the Fellings test. For this test, you have to take Fellings A and Fellings B. Take equal amount of Fellings A and Fellings B. This is Fellings A and Fellings B. Equal amount of Fellings A and Fellings B is taken. Now add the substance. Add the substance that is given to you and mix it well. And mix it well. Now place it in the water bath for 10 minutes. Now you can see the blue solution turning into brown or red color. Okay, the formation of red color shows the presence of a carbohydrate. Okay, you can see this color shows the presence of a carbohydrate. Now we shall see the confirmatory test for amides. Once you get the positive result in soda lime test, the compound may be diamide or monoamide. The presence of diamide may be confirmed by the following test. For that, you have to take now we are going to do biuret test. For this test, you have to take a test tube that is really dry. Okay, in a dry test tube, take the substance and heat it. And heat it strongly. It will become liquid first, and then the ammonia gas will evolve from it. You have to strongly heat until all the ammonia gas is evolved. Okay, you can see the evolution of ammonia gas. You have to heat it strongly until all the ammonia gas is evolves. After expelling the ammonia gas, dissolve. Okay, wait for some time to cool the test tube and dissolve the substance in water. Dissolve the substance in water and then add dilute copper sulfate, and for that you have to add dilute copper sulfate. In the meanwhile, while it cools, I take copper sulfate and dilute it. Okay, very dilute solution of copper sulfate is needed for this experiment, then only you will get a proper color. Then only you will get a proper color, and therefore I am taking copper sulfate. It is already dilute, but you should not, okay, it is dilute, no problem, but I can still dilute this. Okay. The dilute solution of copper sulfate will give proper color, and then The NaOH also I can take dilute NaOH. Take little amount of NaOH and dilute it. Okay. And then once it cooled, and dissolve the biuret in water. Dissolve the biuret in water and then add the dilute copper sulfate. Add the dilute copper sulfate to it. Okay. Add dilute copper sulfate and then add the dilute NaOH. You get the formation of a purple color. That shows the presence of a diamide. Okay. Now there is one more test called a urea nitrate test. You take little amount of the substance. Take little amount of the substance and dissolve it in water. Dissolve it in water and add a few drops of concentrated nitric acid. Add a few drops of concentrated nitric acid. Formation of white precipitate. Okay. You can see the formation of white crystals. That shows the presence of formation of a white precipitate. You can see the formation of white precipitate all over the tube here and also here. Okay, this shows the presence of, this is called as urea nitrate. Formation of urea nitrate is one of the tests to confirm the presence of diamide.